So yesterday we kind of started into this quadratic thing. We talked about the three forms, and now we're actually going to dive into them and look at what they give us, what they're really good for. And like I said, some of them, the vertex is going to be really easy to find from them. Some of them, the vertex might be a little more difficult. X-intercepts might be really easy in some of them. And other ones, they might be a little more difficult to find. So we're going to look at the different forms and see what they're good for. So if I give you something in standard form, the equation is going to look something like this. And here are some of the key characteristics and how you find them. So if you have the axis symmetry, yesterday we had this filled in right here, and we said the way that you find the vertex is you take the x coordinate will equal the opposite of b divided by 2a. We talked about the b and the a coming from the equation. We talked about the b and the a coming from the equation. And then we said that's only the x coordinate. I need an x and a y. The way you find the y is you plug the x in and solve for y. Squared. Okay. And then it wouldn't be quadratic. I know you guys like the camera comms, Cody, but try to write it down too because that there's studies. That's like I didn't have it. Like I had it. No, this is today. This is what they're writing down today. It's okay. Yeah. What's the second word of X-Factor? Quadratic equation. And we kind of talked about what that quadratic equation is. It's opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Fun. Yes?
Is that last word cal?
Yeah, cal. There's a graphic cal, that's awesome. Alright, so here's what happens. Okay. Alright, so for this one right here. For this one, for the axis symmetry. Remember, the axis symmetry is going to go through the vertex. And it's always going to be the x-coordinate of that vertex. That's why it's going to actually be, the equation is going to be x equals, and then whatever that x-coordinate was. Because the axis symmetry is going to run through the vertex. The way you find the vertex is to use this formula, take that x, plug it into the equation, and solve for your y. Now, if you look, the y-intercept is really easy to find if I get standard form. Think about it. Let's go up here. Let's go and talk about why that's so easy. If I'm on the y-intercept, what did we just talk about x being? 0. Yesterday we talked all about it, right? If I'm on the y-axis, my x is 0. Well, let's plug a 0 in. What's 0 squared? 0. Times another number. 0. Does everybody understand why that's gone? What's 0 times b? And what's 0? Because this is plus 0. So 0 plus 0 would be? And 0 plus c would equal? So if I have my y-intercept would be just whatever my c value is. Does everybody understand where I got that from? So that's why down here I said your ordered pair would be 0, c. So if you look at this, the y-intercept is really easy to find when I'm in standard form. Okay. Look at this. X-intercept. We thought we had to have a graphic cal to find it. Right? It's not real easy to find my x-intercepts from standard form. Doesn't mean it's impossible. It just means it's not the best to find the x-intercepts. So if I was actually graphing this sucker, and so looking for this for the future, they give me standard form. They give it to me, and it looks like this, my equation. I go and I find the vertex. Really easy. I can find my axis symmetry. It's the same thing as my vertex, basically. Yes? My y-intercept, really easy to find. My concavity, really easy to tell. That means if I look at A, and A is what? When I say A is greater than 0, what does that really mean? It's positive. So if A is positive, my graph is going to be facing what? Up. And if my A is negative, I can know that it's facing. It's really easy to see. My x-intercepts, you kind of got to do a lot of work. You've got to either factor them, which is what we did at the beginning of the year, or I've got to factor my equation, and then I can find my x-intercepts, or I've got to do that quadratic equation. You heard me rattle that off. It's a long, drawn-out equation. It's not hard. It's time-consuming, and I don't want to spend that much time on it. So if I was graphing this, I would probably not use my x-intercepts. It's not standard form. It's not really good for x-intercepts. Does that make sense? Because when you graph this, you want to find the easiest, fastest way to graph them. The x-intercepts are not going to be good in standard form to be graphed. Are you with me? So let's talk about what can happen since we're on the x-intercepts. Then we're going to actually do an example where I'm going to give you one in standard form, and we're going to graph it. We're going to talk about its concavity, and why we know it's true, and actually when we graph it, yep, that came true, and all that kind of stuff. So here we go. Here's something that can happen. I can have a coordinate plane. I can have my vertex down here. My vertex can be down here. And I can have my concavity up. How many intercepts do I have? How many x-intercepts do I have? 2. 1, 2. So sometimes I'm going to have 2 x-intercepts. How else could that happen? How else? Where else could I have my vertex, and the way the shape of the graph is going, and I get 2? I could have my vertex over here. It could be over here or here. It doesn't matter. Just above the x-axis. And which way is the concavity going to be going? It's facing down. I still have 2 x-intercepts. You good? Well, what happens if I have this? Where else could my vertex fall? It's above it and it's below it. What else can happen? What if I have the vertex actually falling on the x-axis? Could that happen? Sure. How many intercepts do I have then? I only have 1 x-intercept then. It's only touching the x-axis how many times? There's another example of that. It's still only hitting once. Are you with me? Last case, what else could happen? Yeah, it could. But that would still be right on the x-axis. How? You want me above or below? Okay. She's saying put the the vertex doesn't have to be, the vertex doesn't have to be there. It could be over here. It doesn't matter. It's above the x-axis. And what could be happening too? And my concavity could be up. How many x-intercepts do I have in that case? What's the last case that I could have? And again, I have 0 x-intercepts. Are you guys with me on this? You can. If you you want to come back and look at it later and write it and just watch, you can do that because I'm recording it. That makes sense for everyone. Okay. Now, this has to do with what these things, and these things are called roots. They're also going to be our factors. When we get into factor form, I really need to hit why we know that there's going to be 2, how we know that there's going to be 1, and what happens when there's 0. And they're called roots, and they have to do with the X-intercepts. So when we get to factored form, we're going to talk more about those, because in factored form, they kind of give us our roots right away. But remember, standard form doesn't. So let's go and actually do, let's actually do a problem, because I feel like this whole book has been, we haven't been doing something with quadratics yet, and I want to do something. So let's do a problem. Let's go. I give you f of x equals 2x squared plus 4x minus 6. If I ask you on the test, which this could be a test problem, there could be a bunch of different things that I ask you on the test. I could just ask you for the concavity of that. Chris? Morgan? I could ask you just for the concavity. So on the test question, it might just be this right here and say, what's the concavity? Well, look at your chart. How are you supposed to tell the concavity? If I gave you something like this, what do you look at? Look at A. What is the value of A? Positive. I don't need to know that it's exactly 2. I really don't care. All I care is either it's positive or what. And in this case, it's... So what's my concavity going to be? Up. That could be a test question, guys. Or I can have a test question that says, I want you to graph this and label, and then I'm going to give you key characteristics. Label the axis symmetry and tell me what the equation is. Give me the vertex. Give me the concavity. Give me the x-intercepts. Give me the y-intercepts. Are you with me on how I can do, or I could just ask, what's the x-intercepts? What's the y-intercept? And it could just be a problem like that. So I can break these up and chunk them however I need to. So let's do the one. This is going to be a full-on out problem. This is basically everything that I can tell from right here. Are you with me? Let's graph it. When I asked you to graph these things, what did I tell you was going to be the most important thing to find? The vertex. So let's attack that thing first. The x-coordinate, and I know this is of the vertex, is going to be what? How do we find that? What does that say?
Negative b divided by 2a.
Opposite of b over 2a. Okay? That equals what? What's my b? So everybody see, this is a, this is b, and this is c. What is my b value? My b value is 4. But this says to do the opposite of that, so it's going to be negative 4. Over 2 times what's my a value? 2. So I end up with negative 4 over 4, which equals 1. I know my vertex is going to be what? What is it? 1, comma, I don't know what the y is. It can't be 0 yet. You can't just throw in 0 or be like 1, because that's just what we think it is. Negative 1, sorry, thank you. How do I figure out what my y is? That only gives me my y what? Am I worried about my y-intercept here? No? How did I say yesterday? And this is what you've got to get down, guys. When you're in equation and someone gives you an x, or you find an x, How can you find the y that goes with it? Plug it in. This is the x. How do you find the y? You plug in -1 into x. And if you plug -1 into x, you'll simplify all this and figure out what the y value is. Are you with me? Ladies? F of x equals 2 times the -1 squared plus 4 times -1 minus 6. All you do is simplify that, and that will get you the y coordinate of your vertex. And boom, once I got my x and I got my y, I've got my vertex. No guessing involved. With me? -1 squared is 1. 1 times 2 is 1 times -1 times positive 4 is a 2 minus 4 is -2 minus 6 is -8. So I know my vertice is -1, -8. That means on my graph I'm going to go -1, 1, 2, 3, 4, 5, 6, 7, 8. Why am I not too worried about my graph right now? Meaning the way that I drew my coordinate plane. Why am I like, okay, that's good? What way is this graph going to be facing? How do I know this graph is facing up? Because the 2 is positive. So from here, I know my graph is only going to be going, so from here, I know my graph is only going to be going up. Now, what if my concavity was negative? Would this be good to have my graph like this when I'm running out of paper? I would have to shift my graph, and maybe what I do, by the way, does this have to be dead center? Does this have to look where this is the same length as this? Oh, heck no. In fact, let's say the concavity was down on this one. I would have drawn something more along the lines like this, where I had hardly anything up here, because my graph would have started down here and continued down. So I'd want more of this section down than I do. I don't need any of the up graph. Not doctor either. You see doctor up graph? He's down on like St. Pete. So I don't need any of this up part. You guys with me? But in the case that we have, I'm good. Because from here, I know my graph is only going to be going up. Does everybody understand how we found the vertex? Any questions on that guy? What do I know is going to run through my vertex? I know that right through this guy is going to be my axis symmetry. What is that equation going to be? So it's going to read x equals or y equals, because it's an equation. It's going to equal x equals, and what is x going to equal? What is the graph? What is the equation of that line? X equals -1. We already did that, remember? Look, we already did this. And we simplified it to be a -1. No need to do that all again. I've already done it.
So, find like the x coordinate, like using that is the same thing as using the finding the axis.
Because the axis symmetry runs through the what? Every time. So when I do that work, I've already found the axis symmetry also. And remember, the axis symmetry is that line where I know it's going to mirror itself. So yesterday, what did I tell you? How many points do you need to find in order to graph this sucker?
No, 3 you need to find.
Well, I need 5 total. I have to work for 3 of them, and I just mirror the other 2. Right? But what was another point on there? Were the x-intercepts really easy to find on this one? Is that what we said? Oh yeah, let's go for those. Those were easy. So remember, I got 1 point. I just need to find 2 other ones. And I want to find the easiest ones that I can. Were the x-intercepts, did I say those were easy to find when we were using standard form? No, I said they were a pain in the butt, so we're not going to use them. What was another easy point that was really easy to find? Look on your chart. The y-intercept is super easy. The y-intercept is going to be 0, because my x is always 0 when I'm on the y-intercept, comma what? -6, because it's my c value, which is right there. Isn't that a really easy point to use? Then we say we want to use easy points if we have the chance to. So 0 means I don't go anywhere, -6. 1, 2, 3, 4, 5, 6. How many other points do I need to find? I need to work for one more, and then I'll mirror the other ones. I've run out of easy points to find in my eyes, because I don't want to factor. I'm trying to do this as fast as I can. How can I find one more point to the right? That's guessing. Get the right idea in the beginning, but we don't know how high it's going to go. So if I go one more over, what does that mean? If I go over 1, what do I know my x is? So if I go, what's my x here? If I go over 1, what's my x? If I go over 1, what's my x? The old school x and y chart? What did you just tell me you want to know? What happens, where is the y? Because I don't know how high it goes up. Where's my y if my x is 1? How can I figure that out? Oh, you've got to see this. You've got to start being able to do this. If I give you an x, how can you find the y that's with it? Plug it in. Just plug in numbers. Now, why did I pick 1? Because it's just one more to the right. And it's an easy number to use. Whenever you want to know, hey, here's your x, what's the y? Plug it in. That's what I want. I need you to start seeing that. What did this whole thing give us? It gives us the x coordinate for the vertex. How did I find the y? Boom, I plugged it in. If I need to find this one, I was able to find because I knew my y-intercept is really easy to find by just using that chart that we have. 0, c is every time. So it's an easy number. When I ran out of easy ones, I just go, you know what? Let's just go over one more, which I know my x is 1. Let's figure out what the y is. So I go 2 times 1 squared plus 4 times 1 minus 6. Everybody with me? 1 squared is 1. 1 times 2 is 2. 2 plus 4 is 6, and 6 minus 6 is 0. Just by chance, what did I actually find? Just by chance. It doesn't always happen. Not a y-intercept. I found y is 0, but what does that mean? This is where I'm talking. We got to think through. Yes? I made it up. Look, this is 0, or this is -1 is my x. How far, remember, when I'm referring to x, how far left or right did I go? Over 1, that was my x here is -1, and I found out my y was way down here, -8. My x here was 0, and I needed one more point to the right so that I could finish this graph off, so I said, let's go over 1. And so that's why I picked I. Not yet, I'm not mirroring it. I'm still only on the right side. Do you see how? There's the axis symmetry. I'm still only on the right. I said I need 2 points on that right side. I have 1. I just found a second one. Next thing I'm going to do is mirror. Are you with me? What did I just find, ladies and gentlemen? Yes. I just found an x-intercept. It just happened to be an x-intercept. How do I know it's an x-intercept? Where is it lying on? The x-axis. So it's an x-intercept. Now, what I'm telling you is that always going to happen? No. It just happened that I found an x-intercept. Now, I have this half of the graph. find the other half? I go over 1 and up 2, so I go back 1 and up 2. Notice these guys are on the same height, kind of. So I can go over 2, maybe this is a little too, whatever. I can go over 2 and now all the way up to here, and boom, it's mirrored. That's the same process you're going to do for all of these guys. Now the way I get my points, the way I get my vertex is going to change depending on what form I'm in. The way that I get maybe my y-intercept or my x-intercept is going to change depending on what formula I'm given. But the process is, overall is going to be the same. What do we think? Does it make sense? So? Say that again.
Okay. So you went to -1 from
Right here.
x, yes, and then you went to 0. So to find your next point, you go over 1.
Yep.
Each point you move 1.
It doesn't have to. It could move 4. I just picked 1. I'm the one in control. Remember, I get to pick these points. You could pick any point you wanted. If you wanted, you could have put in 100 here. You could have put 100 in here. It would not be smart to do that because your number is going to be massive. Why did I pick 1? Because it was a very smart number to use. It was just 1 over from this one. And when I plugged in 1, it didn't make any of these numbers hairy, scary, or messy. Because eventually, we're going to have fractions up there. Eventually, we're going to have fractions up there. So I'm not always going to move over 1, is why I'm answering your question the way I am. Let's say, and we're going to get to them, but let's say I had a problem like this. I do the vertex, I do all that garbage. Okay? I do all that stuff. And I want to find the next point. And my vertex happens to fall at 1. Okay? Or it happens to fall at 2. X. And so something like this. And I'm not graphing this correctly, so this is not a good example as far as don't go through and try to figure out why I came up with this. Let's say my vertice is somewhere like here. Why would I not, absolutely not, pick 3 to figure out why my next point is that? What would you do with 3 if you were trying to figure out the y for it? Plug it in right now. 3 squared is what? Half of 9 is 9 over 2, 4.5. Who gets to pick these points? I do. I wouldn't pick 3. Why? Because it gave me a nasty number, and I get to choose. I would do 2. I would choose 4. I would maybe choose 6. Why? Because all these numbers are divisible by 2. If I had a 1/3 here, would I want to use 1? Heck no. Because 1 squared is 1, and 1 times a third is a third. Do you think I want to keep going through this problem and dealing with fractions if I don't have to? Would I pick 2? No. Would I pick 3? Yes. 3 squared is 9, and 9 times a third is 3. I can deal with the whole numbers much easier than I can deal with the fraction. And if I have a choice, I have the power, I make it easy on myself and I pick those types of numbers. Are you with me? So that's why I just told you, You don't always just move over one. You have to think about the numbers you pick and pick easy numbers for yourself. So when I was up here, and I was like, hey, I need one more point to the right of it. I looked and I said, okay, if I go over one more and I plug that in, does it make it any kind of nasty numbers? No. And I picked one and I plugged it in and I figured out what the y was. Again, guys, you've got to understand, whenever you pick an x, you can plug it in and find your y. That works for linear, that works for quadratics, cubics, square roots. You can always pick numbers and figure out what the graph is going to look like. Now, you can't rely on that because that will probably take too long to graph if you did every problem like that. But if all else fails and you're like on the EOC or anything like that, pick some numbers. Are you with me? All right. For this one, you're in factored form. And in factored form, it's going to look like this. And here's the way, again, this is the most important part. You're going to find your axis of symmetry. You're going to find your vertex. This one is a little weird. Do you see this R1 and this R2? Go back to the top of this. What does the original equation call for it to look like? It's supposed to be x what? X minus R1. This subtraction sign is supposed to be there. So if I had a factored function that looked like this, what is my R1 value? It's actually 2. What did I just finish telling you? This subtraction sign is what? Supposed to be there. So if that subtraction sign is supposed to be there, my R1 value is sitting right there, which is 2. Are you with me? Now, here's the one that I told you is kind of, and it's tricky, I get it. I told you that before we started this. This is supposed to, the second one is supposed to be a what here? Negative. Is it written there as a negative? How can you rewrite addition? This is where you can see, if you can go forwards, you can also go backwards. X minus, how can I rewrite that? So it's actually the same thing as adding 4. If I subtract a what? If I subtract a negative 4. The reason I rewrite it like that is to show you, there's my subtraction sign. What's my R2 value actually? My R2 value is actually negative 4. That's the trickiest part on this guy. Does that make sense? Now, that's going to be the axis symmetry, because again, the axis symmetry has to go through the vertex. Again, I'm going to find the x coordinate. Whenever you find an x, or you know this is the x that I'm going to be talking about, how can you find the y that goes with it? What can you do? Please get that understanding down. always find it by plugging it in. So let's look at one of these guys. And the reason I'm not doing I'm going to do something a little different here is because I need to explain some background knowledge. So let's say we have this. A little different from the one we just did. But actually, we called this factored form, right? Does everybody understand we called this factored form? Last time, when I was up here, why was it so hard to find my x-intercept in standard form? What did I have to do before I could find my x-intercepts? What did it say you had to do? Factor it. Yes? What? Remember how I told you some things are going to be easier in other forms? Well, what form is this one called? So what do you think it's going to give you really easy? It's going to give you your x-intercepts really easy. Because it's already what? It's already factored. Let's look at what this means. Let's look at what this means. Remember, what does your y equal if I'm doing my x-intercepts? What does your y equals if you are on the x-axis? The y will equal 0. Does everybody understand that? So if I'm finding the x-intercepts, I'm going to say 0 equals 1/2 times x plus 2 and x minus 4. Are you guys with me? Let me ask you, if this bubble right here turns into a 0, what happens to the whole equation? It would be, I'm trying to figure out, when does this equal 0? Well, what happens if this bubble turns into a 0? Why are you saying everything would turn to a 0? Because you'd have 1/2 times 0, which is 0. And 0 times, I don't care what number this turns into, would be what? So if I figure out what x makes this bubble 0, the whole thing would become 0, which is what I want. Are you with me? Well, what happens if this bubble is 0? So don't I have two cases here? I have, if x plus 2 equals 0, what's the whole thing going to turn into? Which is what I want, right? What if x minus 4 equals 0? What's the whole thing going to turn into? Are you guys with me? So, what x would make the whole thing 0? If x equaled what? -2. Or, if x equaled +4. Check it. If you put a -2 in here, -2 plus 2 is 0. 1/2 times 0 is 0. 0 times a -6 is 0. Did it turn the y into a 0 if I put in a -2? Does everybody see that? So what's my ordered pair from right here? -2, 0. What's my ordered pair from here? 4, 0. Did we have cases with parabolas where they could hit the axis twice? Yes, we did. That's what I showed you earlier. Does everybody remember that? We're going to talk about what happens when I only have one and what happens when I have none. We'll talk about this. So if I was going to graph this, I could use my x-intercepts really easy. And I could say, okay, -2, 0, and 4, 0. Do you see how these guys are the same height? They're on the same horizontal line. Doesn't that mean my vertex has to fall where? Let's go up here. I gotta hurry. Do you see how these guys are on the same height? Do you see how this is 1, 2? And this is 1, 2. Do you see how the vertex is in the middle of these guys? Because they're the same height away, right? Well, let's think about that for factored form, because that's where they came up with this equation to find the vertex. Right? They said, oh, if you can figure out this guy and this guy, the vertex has to fall in the middle of them. So if I look at that, 1, 2, 3, 4, 5, 6. Where's my vertex going to have to fall? Where would it be halfway between them? 1, 2, 3. My vertex is going to have to fall somewhere on this line. Now, I don't know how high, and I don't know how low. That's my y. What's the only thing I know right now?
Y.
I don't know why y equals 0. I know my x for my vertex is going to have to be what? 1. Are you understanding, kind of? I know that my x is going to have to be 1. Let's try the formula they gave us. R1 plus R2 divided by 2. What is R1? Nope. Negative 2. Remember, there's supposed to be a subtraction sign there. Plus 4 divided by 2. This plus this is a positive 2 over 2. 2 over 2 equals, what did we just find our x-coordinate was supposed to be? Didn't we find that out because it's supposed to be halfway between these two? How can I find my y? What did I tell you to do? And then you'd plug in and you'd figure out where your vertex would fall on that. We'll kind of talk a little bit more through that. But are we kind of understanding these the way the forms fall?